Good morning and welcome to part number 5 of the Zenith 6D-525 radio. Before I started this video this morning, today is Wednesday morning, I was spending about an hour on this tuning cap here trying to get rid of the short. I found out that there is a short on the antenna part of the tuning condenser. Below 800 kc on the dial, it would short right out. Right now, the tuning condenser is closed, and you can see here I have infinity. I'm going to rotate the tuning condenser. This dial is still rubbing on the faceplate, so if I hold the faceplate over like this, you don't hear that noise. That noise you're hearing is I got my hands on the tuning condenser, rubbing against the wire, so it's showing a high resistance. All right, let me get my... Okay. That's how sensitive it is. All right, so let me see if I can get you right about there. Okay, let me hold that over. All right, the condenser's open. I think you can see that. I can look at the meter. I think you can just about see that in the screen. Condenser's closing. We're at 1000 kc on the dial. About 650 on the dial. And we're closed to 550. Nice and smooth action. Okay, so it looked pretty hopeless on this tuning condenser. It looked pretty hopeless. There was no way I would remove this. I examined the wire that's coming on the bottom of the oscillator section. There's a little short piece of wire that goes down. It's rubber coated. It's buried underneath everything else. There was no way I would remove this. I checked the put the ohmmeter on the oscillator section, but because it's still connected in the circuit, I'm getting a low reading but not a short, and it didn't make any difference where I rotated the capacitor. So I'm not worried about that. On this, I'm going to try to get you up in there, and you're not going to be able to see that, but let me try to get a light on there. I had a hell of a time with my vision. The rotor outside plate was touching up against the stator outside plate on the right side. Okay? And with my smallest precision screwdriver, I could not separate them. My screwdriver kept going and pushing both of them over. I could not see the flat part. This is a Exolite. This is way too big. I have a real small screwdriver on a precision set that I have, and I could not see. I could not tell, no matter what magnification I use, whether the blade on that precision screwdriver was laying flat to the plates or this way. I could not see that, and I kept pushing both plates over to the right. So what I finally did is I couldn't do anything else. I opened the tuning condenser up, okay, and then went to the outside and pulled the plate out, and that solved it. Fortunately, it was the outside plate. I've had this happen on tuning condensers years ago. Usually the outside plates get bent due to handling. Sometimes they're open like this and somebody will reach in to change a tube or something and push this over and short it out. So it's no longer hitting, but I am going to make very sure that it is going to continue working. As I showed on part number 4, I cleaned the switch with deoxide and it's working perfectly. With the meter leads and the extension leads that I have here that will clip on the ohm meter, you know, I got about a half ohm, which is okay. There is a big mystery on this radio, and I can't figure it out. What I want to do is put a polarized cord and plug on this radio. Right now, the neutral or grounded side of the switch is switched. I don't want that. I want to put the neutral on the permanently on the polarized neutral side of the cord, and I want to switch the hot to the 35Z5 plate where the AC comes into, okay? And of course the DC comes out of the cathode. Okay, so that is what I want to do, and let me bring the schematic back out again. Hang on a minute. Now I'm having one hell of a time reading this thing. Because it's so poorly drawn. The biggest issue is, you know, when I mentioned this before years ago on videos, I'm used to seeing a schematic where if you have a tie point, in other words, two connections are made, there is a black dot, okay, at the junction, which will tell you that a connection is made, okay? That is the case on these for the most part, but it's most of the time they don't. And when you don't have a connection, like here, you've got a wire going right through all three wires, okay? You got a resistor here, you got a wire here and a wire here. You don't know where that is connected. It starts here. There's just a tiny, tiny, tiny indication of a connection at that point. With my eyes, it don't permit me to see it. I'm used to seeing this, and I'm going to draw it out for you. Okay. This is what I'm used to seeing. When you got on the schematic that I just showed you, when you got a line, a wire coming here straight down, you don't know what the hell the connection is. Because on those schematics, at least on this one, they're not defined like this. So if it was defined like this, so in other words, if it was like this here, okay, even though the line goes, the wire goes right through these, you know damn well that connection is here, okay? So I would have no problem with that. But that's not what they're doing on this schematic, and it's driving me crazy. I cannot figure it out. And it's holding me back on restoring this radio properly. It's really driving me crazy. I need a better schematic, better drawn out, not the same manufacturer. In other words, unfortunately, Howard W. Sams was the best, was the very best at schematics. However, as I recall, I got to get a coughing fit now. As I recall, I don't think Sams published anything below 1946. So, here is the dilemma. You got three wires here. Again, we're going back into the same thing. This is driving me crazy. I need to get in there and put the neutral on, the neutral wire onto the common negative of the radio filter condensers. Okay? And I can do that directly and bypass that damn wire, which I'll show you again. Okay? So, I cannot figure this out. You've got what appears to be connections going up to here, but it's not telling you. It stops here. So, there is no dot here, there is no dot here. Where's the damn common negative? If you go over here, you look right here. I take it that this is the common negative. I put a plus on this electrolytic here. So these are the electrolytics, 20 microfarads each. This should be the common negative point. But look at where the wire goes. Look at, there's no dot. There's nothing there. So, is this common negative here? At this point, the middle one, or is the next one? I don't know. It's driving me crazy. So the only thing I can do is disregard that damn wire, cut it off under the chassis, I'll show you what it is, and connect my negative, not negative, my neutral from the polarized cord that I'm going to put on it, right at the filter condensers, negatives, okay? And the hot from the power cord, polarized power cord, will now be switched. So this will not be switched. This part of the cord will go directly to the filter condenser, negative, common negative, be the neutral. This is going to be the neutral. This will be a polarized plug here. And this part will be switched. Okay, let me show you under the chassis one more time here. This is the power switch. This is the wire I told you about. Over here there's a black wire, rubber coated, coming off. You can see the flaking of it right there. That wire goes up in here somewhere. Okay, in here. I cannot disturb these rubber wires here, or I'm going to be in deep you know what without a paddle. So what I'm figuring on doing is to just cut this off. Put a piece of heat shrink under it, carefully not to disturb it, and say to hell with it. Okay. Then go to the filter condenser, which is capacitor. I'm starting to use the old term condensers now. And I'm sorry. Okay, you can see that. And put my neutral, of the line cord directly on the case or the negative of the filter capacitor. Okay, now I measure basically 0 ohms when I put my clip lead here on the negative, and I think I think that's a negative. I'm probably pointing to something that isn't negative, but you know what I mean. I can't see, so you'll have to be my eyes for me. The negative of this can, when I put a meter on that and go directly to this wire, which is bare because I've been putting a clip lead on it at the power switch right here. Okay, I get 0.5 ohms. That's what I get with my ohm meter. Okay. that's what I'm going to end up doing. I just want to eliminate this wire so it doesn't short out to the chassis, because the chassis is not common negative. So that would be a problem. So the shell of this is common negative. As I said, when I put an ohm meter between here and that crumply black wire that's on the power switch, because the wrong part of the circuit is switched on these old radios. I don't know why they did that, but they all seem to switch the chassis or the common negative, and that's wrong. But anyways, that's what I want to do. Now, I can't confirm, and it bothers me because I can't move wires around. Normally, you'd move a wire out of the way so you can see it. It's buried underneath the other rubber wires, as I pointed out, under the chassis here. So, I need to confirm it. Yes, the ohm meter shows basically a short. So in other words, there's continuity between here and that crumply black wire that goes to the power switch. I'm going to redo the switch. Okay, I'm not going to switch to neutral side or the... if I'm going to do that, then I might as well just go with a regular, ordinary, non-polarized plug-in cord in the radio like it was designed. Okay? There's no point in going to a hassle of this. Just leave it the way it is and just put a regular cord on it. But I don't want to do that, you know, for safety reasons. This is not a transformer set. If this was a transformer set, it would not matter. You don't need a polarized plug on a transformer set. Usually you don't. Sometimes you get a little leakage on the chassis because of your capacitor that is going from the... You know, sometimes you have a line filter and the capacitor is on the hot side of the line and connected to the chassis. You'll get some leakage there, even if the capacitor is good, and you'll get a tingle sometimes. But we're talking a line connector set, which can be very dangerous. But anyways, we are coming to a point where we're ready to hack this off. Now, we're going to be making very sure that we put a piece of cardboard in here, you know, down here good, so it don't get into the speaker. The speaker's got to be replaced anyways. We don't want no aluminum filings going in here. The problem with sawing this off is going to be a lot of tar in the hacksaw blade. It may be very difficult. The blade teeth will fill up with tar. It may be very difficult to get this off, and I got to be careful. That's why I'm going to what I'm going to do is put a piece of, I got a piece of small piece of galvanized sheet metal. I'm going to stick it in between the speaker and these wires here, so I don't go, when the saw reaches the end, it's not going to go chopping my wires off. That wouldn't be too good. And then I'll take some masking tape, you know, and tape the metal down to the chassis, tape the tube sockets up as I stated, and make sure nothing gets down inside the tuning condenser. So this whole thing will be all taped up. So the filings from the aluminum will only be confined around here and will not get in here. We certainly don't want to get aluminum filings in here. Now, what I did here on this tuning condenser, I further cleaned it with some more CRC, and then I sprayed deoxit in there. The reason is whatever might be in there might be dissolved. I was going to take some cleaner and water and squirt it in there, but then it would get up under the chassis, and you know, I didn't want that, and get into the mica here. Somebody had mentioned about they have a radio and they get static, and if silver mica disease. I doubt very highly these are the type that would have the mica wafers underneath. There's your tuning slugs here, and they're usually the regular trimmer caps type, not the condenser. In other words, the mica condenser, the capacitors that are at the base of the. Those are only for the small tuning. The IF cans, the small ones. Your capacitors are here. So there's no silver mica disease on these type of IF cans. So if you have static, it would be a resistor, most likely a noisy resistor, maybe a capacitor that's leaking or something, but a lot of times that's just resistors. Sometimes a tube will do that too. All right, so I think we're ready to hack this off. We're going to do a hack job. Stay tuned. Okay, I've got the radio on a piece of styrofoam so that the knobs, shafts are pushing through, protect the dial. So we're going to do our hacking. We got a piece of galvanized sheet metal here, and we're going to just saw this down so when the blade gets down to here, it should be okay. We got the tuning condenser taped down so that nothing's going to get in that, and it's the best I can do in here, but we're not going to get anything in the speaker, I don't think, and I'm not too worried about it. That speaker's really bad. Voice call rubs. It does click when I put a ohm meter on it, so it is good that way. We have not checked the audio output transformer, nor have I checked the IF cans. Alright, so let's get hacking. Alright, I hope this does it, because if I have to use my full hacksaw, I may have a problem here, because this is higher up. And I'm worried about this getting clogged up with tar. But we gotta try it. If not, well, we'll cross that bridge when we get to it. I just hope I'm not cutting too short. I'm about a 1/4 inch from the top of that ridge. Let's hope I'm not cutting the terminals off. Not sure, I've never done this before. So, about better than 3/4 of the way through. I've never done this before, so I have no idea what I'm going to find inside there. I just hope that I don't have such a mess that I can't put the solder on to the studs if there are any sticking up inside. You guys that have opened these things up would know what to expect inside. I don't. There it is. I really don't know. So we'll work off camera on that and see if I can do something in there. Well, as you can see, this appears to be loose here. So could put that back on the sleeve over it. That's not a problem right now. We're worried about getting this out without, you know, I got to get at the wires. All dry, that's for sure. I need to get my face up in there, but I wanted to show you here, gently dig this out. What I don't want to do is to damage the wafer that's on the bottom of this, that's separate from this wafer, of course, here. Because if those terminals fall through or are very loose, I'm going to be in you-know-what's creek without that paddle again. So let me stop here and try to clean this. I'll be right back. Alright, it looks like we got two nice studs here, but that's the positive. The negative is the aluminum, which I understand, but I'm not sure. This is a piece of metal, but I don't know if it's aluminum or not. If this is metal, in other words, steel, I can solder to. If it's aluminum, this little area here, I'm not going to be able to solder to it, which means I'll probably have to drill down through, and that's not something I want to do, and then make the connection to the tabs on the bottom. Now the tabs on this electrolytic, or on all can electrolytics of this type, the tabs themselves can't, I don't think they're aluminum, because they're soldered to on the chassis underneath. The ground wires are soldered to that. So I don't know of any way to solder aluminum. I was never able to do it. So I'm hoping, and I'll do that off camera, if I can get a little solder in here, then I can put my ground connection of the 20 microfarad electrolytics in there. So that's what we're going to do. Meanwhile, I'll clean this out. Might be able to use that too. And then put the cardboard sleeve over the whole thing. Well, here's the inside of an electrolytic, in case anybody wanted to know what they look like. Kind of a disgusting looking thing, isn't it? Alright, so we got the can cleaned out. Well, I got to clean it a little bit in there. And that could be put back on with a little bit of maybe electrical tape around the seam here. It's a little rough, but not a problem. We can file it the same way with the radio pod here. We can gently file that because there are little sharp edges here, so that when I work in there, it'll be a little safer. So that is what we're going to do. So I'm going to clean a little bit more in here off camera. And then I got to check and see if I got 22 microfarads. I might have. These are apparently aluminum. This here is aluminum. I cannot solder to that. I was hoping that's metal that I could solder to. You can't solder to aluminum. These studs here, I cleaned them off with my X-Acto knife very thoroughly. I put soldering flux on them. And this appears to be a little loose, but it don't seem to be loose underneath. There is a little dimple in here, very close to these terminals. I'm going to do this off camera because I got nothing to lose. I'm going to drill probably try an 1/8 inch drill first and drill a hole down through. And then I may have to go a little larger because I need to put 3 wires down there, one for each positive of the electrolytic and one twisted together for the other the grounded part of the electrolytic. But I don't know if the electrolytics the leads are going to be long enough, and then put them on and then tack them on to the terminals underneath. Great news! I was successfully able to make a hole in here. Should accommodate 3 wires. Here, I'm going to have to extend the leads. Here is, I think, a 20 gauge Belden. So we need to feed 3 wires down here. I could drill this bigger, and may do that, but I don't want to weaken this thing. I used 4 different drill bits. I started out with a real tiny one that went in very easily. Then I went to an 1/8 inch, and that took a little longer to go through, probably because the damn bit was dull. And then I went to a couple of sizes up from that. And I know I can get 2 of these in there. But whether I can get 3 in there is I doubt it. Well, I can't, because I want to make sure I don't weaken this. This stud is a little bit loose here. I have a feeling it might. The terminals that are soldered to on the bottom can't be aluminum. There's no way you could solder to aluminum. So these must be crimped onto them, and that's my fear too. So if I bring the wires from the electrolytic, which I'll make the assembly up in here, and the electrolytic could be sitting up way up here high, the leads coming down, and then I'll just hot glue them in there, and that'll work out good. So it's a good thing I saved this. Although the sleeve would have been fine, the electrolytic sitting up here and the sleeve going over it, but why not use this? Otherwise it would go in my recycle bin and do me no good. All right, we'll drill that out a little bit after I examine it real close. I got two 22 microfarads at 250 volts, so we'll be definitely good there. I made the hole bigger, but I'm still not going to be able to get 3 leads in here. This is a piece of very thin spaghetti tubing. 18 gauge insulated wire from my Belden roll will only take 1 wire through here, and I drill that out big. I'm afraid to drill it any bigger, it'd weaken the damn thing. So we're still working on it. Alright, I'm going to start making up the assembly. I had to drill that hole out even bigger, to almost 1/4 inch. And I found some thinner wire, because I don't need the 18 gauge. That's what I have in my Belden, so this is some scrap wire. So it'll go down the hole, because I need to have 2 red ones, because they're both identical, both 20 microfarads. So we're going to put them together. Be right back. Okay, we got a heat shrunk, and we got the hook on there. We got to tin this and put a hook in that, pinch it together and solder it, and then we'll put a heat shrink over it. Now what I'm going to do is I'm going to mount these this way. These are going to stick up, but they're going to be folded over after they get heat shrunk. And all the wires are going to come out the bottom. In other words, the electrolytics are going to be upside down. Okay, best I can do. So I'm going to put a heat shrink over the top of it. Do that off camera. Hey, this is going to be the end of the video. I got to charge a battery here on the camera. I've been using it quite a bit. We used some heat shrink on it. In addition to the little pieces that I put on this, brought all the leads down here. So it'll fit nicely inside here with a little wiggle room. All 3 wires should go down this hole here without any problem. We'll do that all on the next part of the video. And we're going to wire it underneath, but we're not going to make a video of that. So this concludes part 5. I think so. I think this is, yeah, this is part 5. So that's the end. There'll be more. Don't go away.